Today we are going to start rational numbers. So, what is a rational number? Any number that is written in the form of p by q, where q is not equal to 0, is a rational number. Or any number that can be written in the form of p by q, where q not equal to 0, is a rational number. For example, if you write 2 by 3, that is already written in the form of p by q, that is a rational number. If you write minus 3 by 5, that is already in the form of p by q. That's why these two are rational numbers. For example, if you write 2, that can be expressed in the form of p by q, that is 4 by 2, or else 6 by 3, etc. That's why 2 is a rational number. Here we have every natural number is a rational number. If we choose 1, that is a natural number that can be expressed in the form of p by q, that is 2 by 2 or 3 by 3, etc. That's why 1 is a rational number. Again, every whole number is a rational number. We have 0 being a whole number that can be expressed as 0 by 10 or 0 by 100, etc. That's why 0 is a rational number. Every integer is a rational number. If you choose minus 3 as an example, that can be expressed as minus 6 by 2 or else minus 9 by 3. That's why minus 3 is an example of a rational number. Here we have set of natural numbers 1, 2, 3, 4, 5 and so on, and set of whole numbers w 0, 1, 2, 3 and so on, and set of integers 0, 1, 2, 3, 4 and so on, and minus 1, minus 2, minus 3 and so on. Thus, we can conclude the set of rational numbers includes 0, 1, 2, 3, 4, 5 and so on, 7 by 2, and so on, 9.86 and so on. Again, minus 1, minus 2, minus 3, which are negative integers and so on, minus 9 by 2, that are negative fractions and so on, minus 5.37, that are negative fractions. Coming to the properties of rational numbers, we have three important properties of rational numbers, that are closure, commutativity and associativity. Let us discuss closure property with respect to natural numbers. We have three columns, that are operation, example and followed by conclusion. First one, we have addition operation. To explain this, we have to select two natural numbers, for example 2 and 3. If we add these two, we are getting the result as 5, that is again a natural numbers. Thus we can conclude natural numbers are closed under addition. Next one, we have subtraction. To explain this, we have to select two natural numbers, that are 3, 5. If you perform subtraction, that is 3 minus 5, which is equal to minus 2, but that is not a natural number. So we can conclude natural numbers are not closed under subtraction. We have multiplication. Let us choose the inputs 4 and 7. Let us perform multiplication. That is 4 7s are 28. That is again a natural numbers. Thus we can say natural numbers are closed under multiplication. Finally, we have division operation. So let us select two inputs, that is 2, 5. Let us perform division with these two numbers, that is 2 by 5, which is not a natural number. Therefore, we can conclude natural numbers are not closed under subtraction. Closure property with respect to whole numbers. First one, addition. So let us choose 0, 3, and if we add these two, 0 plus 3, that is 3, which is again a whole number. Thus we can conclude whole numbers are closed under addition. Next one, subtraction. Let us choose 0, 2. If you perform subtraction, that is 0 minus 2, which is minus 2, but that is not a whole number. Thus, we can conclude whole numbers are not closed under subtraction. Next one, multiplication. We have two inputs, 0, 5. If we do 0 into 5, that is a 0, which is a whole number. Thus, we can conclude whole numbers are closed under multiplication. Next one, division. If we choose 2, 0 as inputs, we perform 2 by 0, but practically we cannot find the value of 2 by 0, which is not a whole number. Thus, we can conclude whole numbers are not closed under division. Closure property with respect to integers. First one, addition. Let us choose minus 5, 3. Let us add these two. That is minus 5 plus 3. That is minus 2, which is again an integer. So we can conclude integers are closed under addition. So we have subtraction. Let us choose minus 2, 4. If you subtract 4 from minus 2, that is minus 6, which is again an integer. Thus we can conclude integers are closed under subtraction. Next one, multiplication. Let us choose minus 5, minus 1, 5. And if you perform multiplication, that is minus 1 into 5, that is minus 5, which is again an integer. Thus we can conclude integers are closed under multiplication. Next one, division. We choose minus 3, 0 as inputs. If you perform division, that is minus 3 by 0, but we cannot find the exact value of minus 3 by 0. Thus we can say integers are not closed under division. Closure property with respect to rational numbers. We have addition operation. Let us choose minus 1 by 2 and 1 by 3. If you add these two, that is minus 3 plus 2, that is minus 1 by 6, which is again a rational number. Thus we can conclude rational numbers are closed under addition. Next one, subtraction. Let us choose minus 1 by 3 and 1 by 4. To subtract 1 by 4 from minus 1 by 3, that is minus 4 minus 3, that is minus 7 by 12, which is again a rational number. Thus we can conclude rational numbers are closed under subtraction. Next one, multiplication. Let us choose 1 by 5 and 1 by 2. If you multiply these two, it is 1 by 5 into 1 by 2, which is 1 by 10. Again, that is a rational number. Thus we can conclude rational numbers are closed under multiplication. So next one, division. Let us choose minus 1 by 3 and 0. Let us divide minus 1 by 3 by 0, but we cannot find the value of minus 1 by 3 when it is divided by 0. Thus we can conclude rational numbers are not closed under division. Now we have the final table for closure property. We know that natural numbers are closed under addition. That's why here addition is passed. Again, we know that natural numbers are not closed under subtraction. So the answer is no. Natural numbers are closed under multiplication. So the answer is yes. Natural numbers are not closed under division. So the answer is no. Again, coming to whole numbers, addition always pass, and subtraction fail, multiplication pass, division fail, integers addition pass, subtraction fail, multiplication pass, division fail, rational numbers addition pass, subtraction pass, multiplication pass, but failed in division with respect to closure property. If you like this content, please like, share and subscribe to our channel. Thank you.